Download this code from codegive.com, link in the description below. Caching is a technique used to store the results of expensive function calls and reuse them when the same inputs occur again, which can greatly improve application performance. The decorator pattern is a structural design pattern that allows behavior to be added to individual objects, either statically or dynamically, without affecting the behavior of other objects from the same class. Here's how you can implement caching in your repository using the decorator pattern in Python. Step-by-step tutorial. Step 1. Define your repository. Start by defining a simple repository interface that has a method for fetching data. For demonstration purposes, let's say we're fetching user data. Python. Class userrepository. Def get_user, self, user_id. Simulate a database call. Print, f fetching user_id from the database. Return id, user_id, name, f user_id. Step 2, create a caching decorator. Next, create a caching decorator that will wrap around the repository method. This decorator will store the results in a dictionary to avoid repeated calls with the same parameters. Python. Class caching decorator. Def__init__, self, repository. Self.repository equals repository. Self.cache equals. Def get_user, self, user_id. If user_id in self.cache. Print, f fetching user_id from cache. Return self.cache user_id. Else. User equals self.repository.get_user, user_id. Self.cache user_id equals user. Return user. Step 3, use the decorator. Now you can use the caching decorator to wrap your user repository. When you call get_user, it will check if the user is in the cache first. Python. If __name__, ==, main__. Create an instance of user repository. User_repo equals user repository. Wrap it with the caching decorator. Cached_user_repo equals caching decorator, user_repo. Fetch users. Print, cached_user_repo.get_user, 1, fetching from database. Print, cached_user_repo.get_user, 1, fetching from cache. Print, cached_user_repo.get_user, 2, fetching from database. Print, cached_user_repo.get_user, 2, fetching from cache. Explanation of the code. 1. User repository. This is the main repository class that simulates fetching user data from a database. The get_user method includes a print statement to indicate when the database is accessed. 2. Caching decorator. This class implements the caching logic. It takes an instance of user repository in its constructor and has a dictionary, cache, to store the results of previous calls. The get_user method checks if the result for the given user_id is already in the cache. If it is, it returns the cached result. If not, it calls the underlying repository method, stores the result in the cache, and then returns it. 3. Main block. In the main block, we create an instance of user repository, wrap it with caching decorator, and then call get_user with the same user ID multiple times to demonstrate the caching behavior. Benefits of the decorator pattern. Separation of concerns. The caching logic is separated from the repository logic, making the code easier to maintain and understand. Flexibility, you can easily add or modify decorators without changing the original repository. Reusability, the caching decorator can be reused with other repositories or methods that you want to cache. Conclusion. Using the decorator pattern to implement caching in a repository allows for cleaner, more maintainable code while improving performance through reduced repetitive data fetching. You can further extend this example by adding features like cache expiration, storing cache in a file, or using a more sophisticated caching mechanism. Certainly, caching is a powerful technique used to improve the performance of applications by storing frequently accessed data in a temporary storage area, cache. The decorator pattern is a structural design pattern that allows behavior to be added to individual objects, either statically or dynamically, without affecting the behavior of other objects from the same class. In this tutorial, we will implement caching using the decorator pattern in Python. We will create a simple repository class that simulates fetching data, and then we will create a caching decorator that stores the results of these fetches to avoid redundant computations. Step 1. Create the repository. We'll start by defining a simple repository that simulates data fetching. For demonstration purposes, let's assume this repository fetches data from a database, but we'll simulate this with a simple method that returns a value after a delay. Python. Import time. Class data repository. Def fetch _ data, self, key. Print, f fetching data for key. Time.sleep, 2, simulate a time-consuming operation. Return f data for key. Step 2, create the caching decorator. Next, we create a caching decorator. This decorator will wrap around our data repository and store the results of the method calls in a dictionary, cache, so that subsequent calls with the same key can return the cached value immediately. Python. Class caching decorator. Def __init__, self, repository. Self.repository equals repository. Self.cache equals. Def fetch _ data, self, key. If key in self.cache. Print, f returning cached data for key. Return self.cache key. Call the original fetch _ data method. Data equals self.repository.fetch _ data, key. Self.cache key equals data store the result in cache. Return data. Step 3, using the decorator. Now we can use our data repository and caching decorator classes together. This allows us to fetch data with caching seamlessly. Python. If __name ___ equals ___ main ___. Create an instance of the data repository. Repository equals data repository. Decorate the repository with caching. Cached _ repository equals caching decorator, repository. Fetch data. Print, cached _ repository.fetch _ data, user1, this will take time to fetch. Print, cached _ repository.fetch _ data, user1, this will return cached data. Print, cached _ repository.fetch _ data, user2, this will take time to fetch. Print, cached _ repository.fetch _ data, user2, this will return cached data. Explanation of the code. One data repository class, this class simulates data fetching. The fetch _ data method simulates a delay to mimic a slow data source. 2 caching decorator class, this class implements caching. It holds a reference to an instance of data repository and a cache dictionary. The fetch _ data method checks if the requested key is already in the cache. If it is, it returns the cached data. If not, it fetches the data from the repository, stores it in the cache, and then returns it. 3. Usage. In the __main___ block, we create an instance of data repository, decorate it with caching decorator, and fetch data. The first call for each key takes time to fetch data, while subsequent calls return cached results immediately. Benefits of using the decorator pattern for caching. Separation of concerns. The caching logic is separated from the core data fetching logic, making it easier to maintain. Flexibility. You can easily add or remove caching without modifying the original data repository. Reusability. The caching decorator can be reused with different repository implementations. Conclusion. In this tutorial, we implemented caching using the decorator pattern in Python. This approach enhances performance by reducing redundant data fetching operations. You can further extend this pattern by adding features like cache expiration, thread safety, or more sophisticated caching strategies as needed.